It worked in mice. It worked in mice.
Welcome back to It Worked in Mice, the podcast where we peek into the lab to see what might be heading to a pharmacy or a self-help book near you in the next decade or two. I'm Piper, and I'm ready to be amazed.
And I'm Alex. I'm ready for my afternoon coffee, but I suppose this will have to do. Let's see what miraculous cures were being promised this week that are still, you guessed it, about 20 years away.
Oh, stop it. You love it. And our first story today is genuinely incredible. It's about spinal cord injuries. Researchers at Cedars-Sinai have found a hidden repair system in the body. It's like our spinal cord has its own secret emergency response team.
A secret response team? Are they like microscopic superheroes in tiny capes? Because unless they can completely fix paralysis, I'm reserving my excitement. What did they find?
Okay, so you know about astrocytes, right? They're these star-shaped support cells in the central nervous system. We always thought the astrocytes right at the site of an injury were the main responders, kind of like the first paramedics on the scene.
Right. They show up, form a scar, and that's that. Not always helpful from what I remember.
Exactly, but this new research found that another group of astrocytes, located far away from the actual injury, are the real heroes here. The scientists are calling them lesion remote astrocytes, or LRAs for short.
Lesion remote astrocytes. Sounds like they're working from home. What do these remote working cells do that's so special? Send encouraging emails to the injured nerves?
They do way more than that. After an injury, there's all this debris from damaged nerve fibers, specifically this fatty stuff from the nerve's coating. It needs to be cleaned up for any healing to happen. These remote astrocytes, the LRAs, detect the injury from a distance and send out a protein signal called CCN1.
A signal? Like a bat signal for the immune system?
Basically, yes. This CCN1 protein reprograms the immune cells, telling them to get in there and become super efficient garbage collectors. They gobble up all the fatty debris, clearing the way for potential repair. The astrocytes far away are essentially directing the cleanup crew at the accident site.
Okay, I have to admit that is pretty clever. The site managers are in a different zip code calling the shots. But, and you know there's a but, this was in...
It was in mice, yes, but they also found strong signs that the same process happens in human spinal cord tissue from human patients. This isn't just a mouse thing.
Strong signs. I'm familiar with those. They usually precede another decade of research that finds it's more complicated in humans. Look, I'm not saying it's not cool, it is. But I see a headline about healing spinal cord injuries, and I think of people who could use that help today. This feels like a very, very early first step.
But it's a huge one. For years, scientists have been trying to figure out how to clear that debris effectively. Now they've discovered the body has its own system for it. Instead of inventing something new, we might just need to figure out how to boost this natural long-distance communication network. It could have implications for stroke, MS, all sorts of things. It's a whole new playbook.
A playbook written for mice. I'll check back when the human edition comes out. What's next? Please tell me it's something I can actually use.
I think so. This next one is about protecting your brain from Alzheimer's disease, and it's something you can start doing right now. Or, ideally, something you started doing as a kid.
Oh no. Don't tell me it's about that kale smoothie I refused to drink this morning.
No, it's about lifelong learning. A new study in the journal Neurology found that people who regularly engage in brain-stimulating activities throughout their entire lives have a significantly lower risk for Alzheimer's and cognitive decline.
You say lifelong learning, and I hear homework forever. What kind of activities are we talking about? Does trying to understand my streaming service's new user interface count? Because that's a serious cognitive load.
Maybe. Specifically, they looked at things like reading, writing, learning new languages, playing games, and even visiting museums and libraries. And they tracked this engagement from childhood through midlife and into old age.
So my parents forcing me to go to the library as a kid was actually a long-term neuroprotective strategy. Sneaky. What was the payoff? Did it lower the risk by like 5%?
Try 38%. People with the highest amount of lifelong learning had a 38% lower risk of Alzheimer's. And even more impressively, for those who did develop it, the onset was delayed by an average of 5 years. Mild cognitive impairment was delayed by 7 years.
Okay, 5 to 7 years, that's not nothing. That's a lot of extra time. So it's not about just picking up crosswords when you turn 70. It's about building up what they call a cognitive reserve over your whole life?
That's exactly it. You're building a stronger, more resilient brain network over decades, so when the pathologies of Alzheimer's start to appear, your brain has more capacity and more alternate pathways to withstand the damage before symptoms show up. It's like building a much bigger fortress. A few cracks won't bring the whole thing down.
A fortress of knowledge. So my complaining about having to learn French in high school was actually me just laying down some solid defensive walls. I suppose I should thank Madame Dubois. Still, the idea of constant enrichment sounds exhausting. My brain needs a break from all this. Learning. I'm building my cognitive reserve by resting it. Give me 10 seconds.
It worked in mice. Worked in mice. That sounds real nice.
Sounds real nice.
Will it work for you? Let's find out what's true. It worked in mice.
And he's back! Did your brain feel the burn of knowledge, ready to load up some more data?
Barely. My astrocytes are still trying to process that first segment. All right, let's move on. What's next on the menu? And I mean that literally because I'm getting hungry.
Perfect timing. Our next topic is all about when you eat. We've all heard of time-restricted eating or intermittent fasting. It's incredibly popular, but a huge new analysis of over 40 previous trials has tried to answer the big question, does it matter when your eating window is?
I have a feeling I'm not gonna like the answer. My eating window is generally when I am awake. Let me guess, they want me to eat dinner at 4 p.m. like a retiree in Florida?
You're surprisingly close. The study found that an early or midday eating window provided the most metabolic benefits. We're talking better outcomes for body weight, waist circumference, blood pressure, and fasting glucose levels compared to people who ate late in the day.
I knew it. This is a direct assault on the sacred ritual of the late-night snack. So my body is judging me for that 10 p.m. bowl of cereal?
It's not judging, it's just less prepared. The researchers think it's about aligning with our natural circadian rhythms. Our bodies, including our metabolism and insulin sensitivity, are just more efficient and fired up earlier in the day. Think of it like a factory. The day shift is fully staffed and running at peak capacity. The night shift is a skeleton crew. They can get the job done, but it's slower and less efficient.
So, eating a brownie at 10 a.m. is metabolically superior to eating a salad at 10 p.m. This is the kind of science I can get behind. I've found my loophole.
Not quite. The quality of what you eat still matters immensely, of course. But the study suggests that shifting your calories earlier in the day gives your body a better chance to process everything effectively. The least effective pattern they found was a late-in-the-day eating window that was also longer. It seems to work against our internal clocks.
So the takeaway is, be a morning person who eats like a hobbit, breakfast, second breakfast, 11s, and then just stop. I suppose it makes sense. It's just deeply inconvenient for my lifestyle. All right, what else have you got to ruin my day-to-day habits?
Last one, and this one is going to make you question that bottle of supplements in your cabinet. It's about omega-3 fish oil. For years, we've heard about its benefits, including potentially fighting cancer. But the results from big studies have been all over the place. Some show a benefit, some show none, some even hint at an increased risk.
See, this is what I'm talking about. It's a scientific coin toss. One year it's a miracle pill, the next it's a waste of money or worse. I love the chaos. So, what did they find out this time?
They may have found the reason for the chaos. Researchers discovered that the cancer-fighting properties of omega-3s seem to depend entirely on the presence of a specific enzyme produced by a gene called ALOX15.
A-LOX what now?
ALOX15. The point is, it's a key piece of machinery. In their mouse studies, when this enzyme was present, the omega-3s helped suppress colorectal cancer. But in mice that lacked the enzyme, the fish oil supplements, especially one type called DHA, sometimes increased tumor growth.
Hold on. Let me get this straight. You take a supplement you think is good for you, but if your body is missing this one specific gene, you could actually be making things worse? That is terrifying, and also, dryly, completely on brand for the supplement industry.
But think of the positive side. This is the future of personalized medicine. Instead of this one-size-fits-all approach where everyone just takes fish oil, imagine a future where a simple genetic test tells you if it will actually benefit you. It's about being smarter and more targeted, not just throwing supplements at a problem and hoping for the best.
Or, and hear me out, it's a sign that we should be more skeptical about taking concentrated pills and maybe just try to eat a balanced diet, like with actual fish, which presumably comes with all the cofactors and enzymes needed to not be harmful.
That's always a good foundation, but this research is so important for understanding why things work. It explains the conflicting results and paves the way for making supplements safer and more effective for the people who can truly benefit. It's not chaos, it's a new layer of understanding.
SOF. It's an expensive new layer. Soon you'll need a full genetic workup just to navigate the vitamin aisle. I can see it now, a 23andMe kit just for your supplement regimen.
I think that sounds amazing. Why wouldn't you want to know what works specifically for your body?
Because I prefer the blissful ignorance of just assuming my multivitamin is doing something magical. All right, let's wrap this up before you convince me to get my ALOX 15 levels checked.
Okay. So today we learned that our bodies have an amazing long-distance repair crew for spinal cord injuries, that building a fortress of knowledge throughout your life can literally give you years of extra healthy brain time, that eating earlier is better for your metabolism, and that the future of supplements is all about your personal genetic makeup. It's all so hopeful.
And I learned that I need to start doing homework, eat dinner before the sun goes down, and that my fish oil pills might be plotting against me. Another week, another round of life-altering advice that worked in mice. Dryly join us next time to find out what else we're probably doing wrong.
It sounds real nice. Will it work for you? Let's find out what's true.